All right, welcome to the August TriEmbed meeting. I don't see any new visitors, so we don't need introductions. Announcements, anything going on in the area that we ought to know about?
There will be, towards the end of August, a meeting at the Apex Town Hall regarding the scanning tunneling microscope. Just general, anyone who wants to come. Maybe nobody comes, but we'll deal with it one thing at a time. It's part of the reason I'm working on the Etcher code is to improve that. And sometime in September, well, I'll go through it. I will be running a course in holography, if anyone is interested.
Hey,
I have an optical table, I have lasers, I have film. You actually get to make one of them. They're hologram things.
So when you can come up with a holodeck, then I'm going to be really interested.
Well, I'm sorry, it is for you. So I can make you a little, 2-inch by 2-inch hologram of a Star Trek figure. That's all you get.
You do know what a holodeck is, right? Star Trek and whatnot.
Yes.
Yes. Okay.
I am that old.
Okay. You mentioned a course. I am teaching a introduction to machining class at Durham Tech. It's a continuing education class with no prerequisites required. Starting the first Tuesday in September. Let me see what that date is. August the 3rd.
Do we have to pay for this course as we're friends?
Yep. It's
And how much are you going to charge us for this course? What's the friends and family rate?
Everybody pays the same amount. It's 100 and something. 100 and you'll have to look it up. Just a little over $100. It's meets 8 sessions in the 9 weeks starting September 3rd. There's one Tuesday in September where I'm out of town that we will not be meeting. There's 10 seats available, and last time I looked, there were 5 students signed up.
What was the name of the course?
Introduction to Machining, I think it's called. Let's see if I can find it online for you guys here.
Do we get to do machining?
Yeah. Yep. So there are 5 mills and 5 or 6 lathes. We'll be doing drilling and milling and turning and
hammering. Do I get to learn hammering?
Hammering? Sure, if you want to do some hammering. We got hammers and vices and metal, and now we won't be doing any forging or welding.
No smashing of computers, huh?
They do have a pretty good, maybe I think a 50-ton press that you could compress.
There's an idea. There's an idea, Nick. Take that computer and stick it in the press.
Yes, I can make it, from a laptop to a handheld.
All right, let's see. Continuing education.
So, what is, do we just kind of go in there and then you let us free to do what we damn well please, or?
No, I will be
The
going
father
over
figure.
topics. Here it is. Hang on. So I taught it in the summer, and we built steam engines, quote unquote steam engines. It was a little bit ambitious. And so only about half the students finished, and I had to make some of the parts for them. So we won't be doing that same project again. We'll probably be making C-clamps and doing some drilling, threading, counter boring, countersinking, different cutting slots.
I have a suggestion.
Okay.
Why don't we make a Stirling engine?
That's possible. A
It's
lot of
easier
these.
than a steam engine, a hell of a lot safer.
Well, we used compressed air instead of steam, so that's safer. But it was just the amount of things that had to be done. It wasn't all that complex, but it turned out to be more than
Just, yeah,
8 sessions
but it'd
worth
be
of
good.
work.
How about an electric wankle?
No.
You get that in other areas of storage.
How about when I was in 7th grade, I made a hook scriber in shop class on the lathe, and heat treated the ends of the scriber, and I still have that somewhere. Did some knurling and some turning, and
It'd be just fun to make a Stirling cooler.
okay. Any other announcements? All right. Well, let me start presenting here. All right. Is that working?
Yes, we see it. Fine.
Good. So this is a little bit more involved setting up the problem, but hopefully you'll find it interesting. So I have a rain gauge. Years ago, I had a wireless rain gauge and temperature that presented on a little battery-operated screen. And the rain gauge stopped working. The temperature I still use, but and so I stuck it in a bin. And when I started doing Arduino stuff, I opened it up and ripped all the non-functional wireless stuff out of it and ran a wire to it, and converted into an Arduino capable rain gauge. I think my next picture, let's see, page down. So it's a tipping bucket rain gauge. It's got a little seesaw with 2 buckets that collect water. And as the water collects in the uphill bucket, the center of gravity shifts and the teeter-totter tips. The water dumps out of that bucket, and the other bucket ends up under the inlet. Yeah, so there's a picture of it. The cover has been removed. It's got a funnel that drips down right about over the center line here.
Did you make that, or did you buy that
No,
thing?
no, I bought this. It used to have a couple of batteries here and a little bit of electronics with a radio of some sort, a reed switch. There was a magnet in this little hole here, and as the seesaw tips, the magnet goes past the reed switch, and the radio circuitry there detects it and adds +1 to the display.
Somebody needs to kill their mic or something. Getting a lot of echo.
And so for most of my home automation, I use D1 minis. This one was actually the light version, which was I think a ESP8268 or something, has a little bit of embedded RAM. So it doesn't have an external RAM chip for the programming. Custom shield that I designed. And then about 40 feet of Cat3 phone cable from the shield to the rain gauge to the Hall effect sensor. I don't know where I got this sensor. This was all done years ago. It's got power, ground, and an open collector output that so this transistor either conducts or doesn't conduct depending on how the magnet has gone by the Hall element. From the data sheet, it says it's supposed to operate at 5 volts to 16 volts. I've been running it at 3.3 volts, and it's worked just fine for a number of years, but keep that in mind. So here's a picture. The D1 Mini's down here. This is a blue board. The purple board from Osh Park is my shield. One of these is the Cat3 that goes to the rain gauge. There's also this little battery pack here and another Cat3 that goes to my drip irrigation valve. There's an N-channel MOSFET here, so there's some additional circuitry on the shield.
Are there 4 wires in the Cat3 or 3 wires?
There are 4 wires,
that's what I
2
thought.
twisted pairs, the orange and white pair and the blue and white pair. So what I ended up doing with the unused connector is running VCC back from the sensor back so that I can detect wire breaks. Maybe if the wire gets cut, that would no longer have 3.3 on it, and I could hook it up to a digital pin and monitor that. I actually don't do that. This wire that's not doing anything right now is that return supply. All sensors come in different configurations. This one is a latch. When it sees a north to south, it latches one way, and when it sees a south to north, it latches the other way. I didn't want to have to detect a small pulse as the magnet moved by. So using this latching kind was a whole lot easier. I just had to do level sensing as opposed to edge sensing. So in software, I do level sensing, and when the level changes, I call that an edge, and I accumulate a counter and send it to my MQTT broker. I back up the count in EEPROM so that if power goes off, I don't lose what my current count is. And then about 32 tips of the teeter-totter equals 1 inch of rain. So here is some data that I collected between 2020 and 2023. I just let this counter go. And every once in a while, for reasons I don't fully understand, it resets, sometimes to 0, sometimes not to 0. I assume that's some kind of a software glitch. But as you can see, this is kind of monotonically increasing until something happens. There are some data outages when, for whatever reason, I wasn't collecting data. And then a month ago or so, sometime in July, it just stopped counting. It was stuck at 101, even though it was raining. It never saw edge transitions. So the sensor has these 3 wires, voltage, ground, and an output that's connected to one of the digital GPIOs. As I mentioned, there are some other things going on in the system which I haven't really described here, but all the other stuff has been working normally. At the end of June, it stopped working. The device is down in the crawl space, so it's a little bit cumbersome to get to. Suspecting the issue was the Hall effect sensor, I went down there and unwired the wire to the sensor and undid the wire and brought the whole thing into the workshop. And so I hooked up power supply to the VCC and ground. I could play with the voltage. And then with a voltmeter, I measured what was happening on the output pin as I waved a magnet nearby. And I could see 2 different behaviors depending on whether I swiped it forward or backward. Like 81 millivolts and like 0 millivolts. So it seemed like it was doing something, but 81 millivolts wasn't, I was expecting more than that. I looked through my stock to see if I could find another Hall effect sensor, figuring I'd swap that one out and see if that fixed it. I couldn't find it. So I don't know if I bought one. It's not like me to buy one of anything. I usually buy 5 or 10 whenever I get a little
I think
price
we can
break.
all say that.
So I'm sure I have 8 or 9 of them in a packet somewhere. So I went to DigiKey and I found that it's no longer being manufactured, and they recommended something similar. So last Thursday afternoon, I ordered 10 of them and chose UPS Ground Advantage 4 to 5 day shipping. And lo and behold, it showed up on Saturday. I could not believe it. The post office has really worked hard to make sure that their 4 to 5 day things don't get delivered in 1 or 2 days. They don't want to set those kind of expectations. And so when I get things from Osh Park, it'll be, say 4 to 5 days, and I watch the transition. It'll go from, Oregon to Raleigh, and then it'll sit in Raleigh for 3 days before they deliver it. But this showed up. I was dumbfounded. So I was thinking, 81 millivolts, that's not enough for a logic 1. What's going on? But then as I was looking at the code, I saw that it was input pull-up. So I said, okay, that makes sense. So I added a 10K pull-up resistor. Now, again, this is the sensor not hooked up to my shield, not hooked up to the D1 Mini. This is just directly hooked up to power, and with the 10K resistor, I was getting 3.3 volts one way and a couple of millivolts the other way. So that's what I was expecting. So
Yeah, I mean, if it's open collector, you have to have a pull-up resistor.
okay, and I do. I didn't
10K
realize that.
10K is normal.
Yep. So it seems as if the sensor is working, even though it's only at 3.3 volts. I actually turned it down to 3 volts, and that worked down there as well. So I said, okay, well, maybe it's my D1 Mini, and so I pulled another one out of the box and programmed it with the code for the rain gauge, and I reconnected everything. I had to go under the house and rewire and drag wires around and pull and swap boards. And so instead of dragging my voltmeter down there, I just figured I'd look at the MQTT broker messages of seeing whether it was a 0 or a 1. So this is what my code sends to MQTT. I adopted the style that Tasmodi uses for. So this is telemetry. This is the lower 6 bytes of the MAC address. And this is the sensor output, and the message. It tells me what software I'm running, what the signal quality is, what the min and max signal qualities I've seen, what my drip irrigation valve is either open or closed, how many times it's opened, how long it's been in the current state. And here's the number of rain tips and the current state of the Hall effect sensor in the rain gauge. And then the most recent error it's seen, the battery stuff for the drip irrigation. So by watching this, when the teeter-totter is in one position, this should say 1, and when it's in the other position, it should say 0. And the count is that thing that you saw being graphed. It's the number of edges or the number of tips of the rain gauge. So with the new Mini, and actually replaced the Hall effect sensor, the results were the same. No change to RT when the bucket was tipped. So I brought everything, undid everything, pulled all the wires from under the house, brought it in, and hooked up my voltmeter. And so instead of seeing 0 and 3.3, I was seeing 0 and 0.4. So why isn't the internal pull-up working? Maybe it's something I did on the shield. The Hall effect sensor attaches to these 3 pads down here, these screw terminals, which is just VCC ground and GPIO4. There is a jumper that I put on the board so that I can run this off of either +5 or +3.3. It was jumpered for 3.3. So I didn't see anything wrong in the board. It's been working great for a couple of years. So, but I took the shield out and hooked up the sensor directly to make sure that it wasn't something weird going on with the shield or one of the other components on the shield doing something. And then I got to thinking, well, maybe there's something wrong with GPIO4 on this board, although this is the replacement one. But it turns out that GPIO5, which is the pin next to GPIO4, it was getting 0 volts and 3.3 volts as I expected. And GPIO0 also was doing as I expected. So here's the D1 mini pinout. There's GPIO4, GPIO5, pretty much identical. GPIO0 is pretty much identical. They've got some alternative things for the built-in SPI library uses those 2
Right.
pins for SCL and SDA, and when you flash the program, GPIO0 does something, but
So I was wondering if maybe once I saw that, I was wondering if maybe somehow or another the software got set up for the wrong mode on the GPIO4 pin.
There's a weirdness, and I can't recall precisely what it is, but there's some numbering weirdness which has changed in the software between which assigns the numbers to the GPIOs. And I looked at it in the IDF toolkit and didn't explore it because it didn't make any sense to me. It could be that you've hit that and if it is the compiler you're using now thinks GPIO4 is GPIO5, because there was something about that in the something weird about that.
well, so I changed my code, right? And if I use GPIO5 in the code and hook up the output of the Hall effect sensor to that pin, I can see it going between 0 and 3.3 volts. If I change the code to GPIO0 and hook it to that pin, I can see it going from 0 and 3.3 volts. If I change the code to use GPIO4 and use that pin, I see it going from 0 to half a volt, 0.46 or whatever. And it changes as I move the magnet back and forth. So that's kind of bizarre.
Take a look at the data sheet and see if they're using GPIO4 for anything internal to the processor. And maybe what you're getting is something else is using that pin.
Okay, that's certainly a thought. I mean, Arduinos, you pretty much are supposed to own the whole machine. ESP, certainly, this is a single processor between calls to the loop function. It is running the Wi-Fi stack and some other stuff, and so that certainly, as you say, it could be doing things with other pins. I'm fairly confident that this stopped working at a time where I wasn't mucking with the code. I mean, this was working fine for a long time. It's possible I changed something in June for some reason, but
But there was a that you are running your rain gauge or your drip irrigation on it.
I am. That uses a different pin, right, to drive the gate of the MOSFET to send those 2D batteries to a solenoid that turns the water on and off.
So it's just on, off, up, down, or high, low.
Yep. Yeah. So this chip only has one analog pin. That's this ADC 0 pin here. It's an input only, so all the rest of them are just digital output pins.
Right, I mean high, low versus like a protocol.
Yes.
It's like a relay or something. You're just on or off.
Yep. And there is a shaft, a valve open, closed switch. I think it's a shaft position sensor or something as well on the drip irrigation. So I run the motor until I see the switch change state, and then I stop the motor, and that tells me that the valve has gone from what it was to what it is. And then after I've watered for a while, I run the motor again till the shaft sensor changes state again. And all that's been working for years. So I didn't see anything in the pinout reference about GPIO4 being special. So then I said, well, let's try another D1 Mini. And this one worked just fine on GPIO4, running the same code.
Well, I think that explains it. You got a bad one.
I got two bad ones.
Bad too.
So the one failed after 3 years. I can believe that. But what are the chances that I pulled one out of my stock and it had a low pull-up on GPIO4 as well? That seems
it
quite
happened.
a coincidence. It did happen, so it's 100% probability. So I have not plugged the shield and the rain gauge. Is that true? Yeah, into the third D1 Mini. I mean, so potentially something with my setup is doing bad things to GPI, to that input pin.
Yeah, I was thinking that too. Maybe you're drawing too much current from it and frying it
How
internally.
long do you have a long wire from the GPIO pin to your house?
Yes, 40 feet.
Do you think you might be getting an inductive kick on the wire, which has blown the pull-up or weakened it?
That's possible.
I mean, you might just try putting a Schottky or a clamp diode to. I mean, if it pulls low, and then releases it, you're going to get a kickback over 40 feet of wire.
Yeah, that's possible. The other thing you can try is actually stick your own pull-up in there and see if it fits.
I did. And so when I put the 10K pull-up on the replacement D1 Mini, right, it went from 0.46 volts to 1.2 volts.
But not the 3 you wanted.
But not high enough to get
Yeah.
the logic.
It definitely sounds like the Mini has got a problem.
Yeah, I would, if you put the pull-up resistor at the other end of the 40 feet, then you will not get reflections. It will match the impedance a hell of a lot better.
Okay.
Another way of doing that is to use an op amp. One
Sure,
may,
I could detect the 81 millivolts instead of trying to pull it on a logic pin.
You've got more than you've got 100 nanoseconds of round trip that the signal is going to take, and that could give you a kick.
Where? How does the wire run? Like what?
So when it was attached to the replacement D1 Mini, which was in my
I just mean, how was it run
yeah,
originally?
yeah. It runs out of the crawl space through the door, along the siding, behind a gutter, downspout, under the porch, to up on the railing of the porch, where the rain gauge is affixed to the railing. There might have been a small coil of 4 or 5 turns of excess cable in the crawl space near the D1 Mini. The signal is on the twisted pair with the ground wire. So they run as a twisted pair, signal and ground for the 40 feet. The 3.3 is on both of the twisted pair that's adjacent to the on the orange ones, and the blue ones are the ground and signal.
Not running over a long ways outside, but like, is there any chance you had, lightning, electrical storm
In the last
interfering with
4
that wire?
years,
Oh, around the time that you
Yeah.
had the issue,
certainly that's possible for the original one, right?
But
Yeah.
yeah.
I can't explain
Mm.
how the second one gave up the ghost
Yeah,
immediately, right?
I think you either need to do what Nick recommended or put some sort of buffer on there so that you're not actually running, so that the mini pin doesn't actually see the impedance of the wire directly, and that it goes
I mean,
through.
100 picofarad, a small capacitor would tend to smooth out any kickback you're getting. But if you got two that have died, then you're doing something to kill them.
Well, I don't know, because the first one, I mean, after 4 years, I mean, and it gave up the ghost after 4 years. I'm not sure he did anything to cause that one. The second one he may have, but the first one I doubt.
But it didn't work right away, right?
That's right.
But is it possible that in the past you had a problem and you're just like, I'll switch this out, and threw it in your drawer, and now
I
you pulled it out?
guess it's possible. I generally, when they stop
And
working, I stick a little sticker on them and then write bad on it.
Yeah, I've done that.
So this is one that hadn't been done to it.
are the 8266s from the same batch?
No.
Then it's gone through numerous die shrinks. The original one was probably done on a with photoresist. They spread with a butter knife, and they've shrunk it down to nothing, which means it's going to be far more susceptible to a kick.
Well, the third one would be the most recent and smallest, and the
Mm-hmm.
D1 Mini Lite, the original one, was probably the oldest.
How much are these things?
Cost?
Yeah.
$2.
Yeah. Okay.
Yeah,
So
the Mini Lite is 250 and the D1 Minis are 350.
So, I mean, I'm assuming, as you say, usually buy 10 at a time, you've got other ones.
Oh yeah,
Stick one out there and see what happens through the next thunderstorm. If it blows up again, you probably do need some sort of buffer between the
sure.
mini
I'm just
and the
worried that
wires.
if I plug it back in, that on a third one, it will do what the second one did, and it will immediately give up
Break.
the ghost.
Oh, so
And
it did
Let's
it
see the.
immediately?
it never worked. The first
Oh,
one worked for 4 years. The second one never worked that I know of. And I'm a little reticent to try it on the third one, but
yeah, I
I
can
probably
understand.
will. You know, I have the third one with the sensor hooked up, and it works. Not the I don't have the I'm not using the sensor that's in the rain gauge with 40 feet of wire. I'm using another one of the 10 that I bought with 8 inches of wire. But it's in my,
Well,
in my living room or my computer
I
room,
I think if
and
you were able to put something on the line that helped protect it from surges, and you were confident everything still worked while it was in the house and not in its uh, 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 in the location where you're going to use it,
yep,
then and everything works, I'd just stick it out there and see what happened. I
okay.
mean, I
That's
personally
probably what I will do. It's a small investment. The other thing that I can do is I can go back to
But,
the
but
original one and use put a little jumper between GPIO 4 and GPIO 5 and change the code to use GPIO 5, and maybe I'll get another 4 years out of it. And then after that, I'll use GPIO 0, and maybe I can get another 4 years out of it.
there you go, 12 years on
but
little mini.
put a little cap on the thing just to cool it down a little bit.
Okay, so a
And
cap from
that's
where to where? From the output
from
pin
ground
to
to the
ground?
output.
Yeah.
Just to if there is a kick coming back, um, you know, uh, point oh 0.01 would be wonderful. Just a
0.01.
little
Okay.
bit to to make it gentle.
Yeah.
Yeah, too
Value
high,
is not.
and you're going to have a lot of lag.
It, yeah, you're gonna have slow rise time, but you
Yeah,
know,
but the rain gauge, you know, if when it's really raining really fast, how long does it take to get an inch of rain? 10 minutes, 5 minutes, 30 tips in 5 minutes. So we're talking about, the rise time, as long as it's under a second, I'm going to get the
mhm.
right answer.
Yeah,
Yeah, just cool it down a little bit, and the ESP32 has a built-in Hall effect device.
The original 32 does. The
Yep,
C3s and the S2s and all
does.
those, they no longer have that.
Yep.
And I don't know that it's
They're
a
also kind of in the
latch.
wrong place, right?
Yeah,
They're
it's
not
in the crawl
40 feet
space,
away.
not in the. And I don't think it's a latch. I think it's a senses um, the presence of either the North or South Pole. I forget which.
You said you measured the voltage on those things when they were disconnected. This is the output pin, right? When it's connected. I was just curious if you see any voltage across those two wires normally, like if it's picking something up, like when they're not connected, like the 40-foot wires just across those two. When
is
you're
that
not
your
sending
dog,
anything
Nick?
out.
No, yeah, it's not my dog. It's the other dog in the house.
Oh,
My dog is sleeping.
But Paul, like, what about voltage across the 40-foot wire, like when it's not connected? You know, any chance something's inducing a voltage on that or whatever? Is
The
Paul
fact
on
you're
mute?
running a magnet right next to the wire probably will induce a voltage.
Paul, did you hear him?
I think Paul got muted, maybe.
Somehow or another, he doesn't hear us, I think.
I'm sorry. I somehow I got muted. Yes, I hear you.
Okay.
There are 4 wires in the cable, right? It's a twisted pair of blue and a twisted pair of orange. So the twisted pair of blue is soldered to 2 and 3 of the Hall effect sensor. And so you're saying measure the voltage across those 2 wires while it's
But from the crawl space side, in case it's running
yeah.
alongside something that, you know, whatever.
Okay.
AC, DC, you know.
Yep. I can do that with it sitting here in my room
Yeah,
here.
I didn't,
Pull
Put a
the whole
point
thing
I
one
didn't
at
even
inside.
the
think
side.
of that. You could have, right, AC, a 60 hertz AC wire inducing
Put
a
a point.
voltage.
So I did
Put a
hook
point
up
one across the power supply too.
my scope to the output pin. And I don't see anything going on that signal. I can see it rising and falling. There's no bouncing. If there's any AC, it's much faster than 60 hertz.
The whole thing, including the 40-foot wire inside your shop here.
No, I think this was short,
Yeah, I was just thinking
but I can.
on either end of the actual run, in case it's run alongside something,
Yep.
or whatever. But you're asking whether you should hook your new one up, and that was the kind of thing I would check for, is if there's
Okay.
stuff like that going on it. Obviously, transients from lightning storms, you know. I like Nick's idea, some kind of a capacitor.
Yeah.
Can you put a diode across there also to shunt any reverse EMF?
I could. Yeah, I guess I was done with all my slides.
The architecture of the driver is that there's a protection diode usually on the output, but if you exceed the current through the protection diode, it turns into an SCR and does nasty things.
So I did run this GPIO4 as an output pin, and I was able to see that go high and low. I ran it as an input pin and fed 3.3 to it, and it read it as high, and when I put it to ground, it read as low. I don't recall if I tried input pull up with a floating input. That would be interesting to see whether it would pull that high or not.
Put a cap on the thing, put a cap across the power supply. If you blow it up, I'll give you another one for free.
I've got plenty. So from pin 1 to pin 3. from VCC to output. 0.01 cap.
Yeah, put a 0.01 across the output to ground, and then put put a small cap there, and put a much bigger cap across the
From
ground to the
VCC to
power
ground.
pin. Yeah, just,
Okay.
because that's just a good thing to do. It will give you brownie points
Okay.
in engineer's heaven.
All right. Any other comments or suggestions or?
No, except I'd like to know what happens.
Okay. I will be sure and report next month. So I missed, we got almost 6 inches of rain from the tropical depression, but I missed recording it.
When I took a shower this morning, the shower basin started to fill up with water because there was so much water outside that our entire sewage system could not drain properly.
Oh,
It
wow.
did go down within a minute or so, but I've never seen that before.
Don't flush the toilet.
Yeah.
Huh. Okay. Show and tell. Anybody done anything fun last?
You still, by the way, oh, okay, you killed it. You were still sharing.
Yep, I turned it off. Hello, Dawn.
Dawn T.
Muted. Nick, you still wanting to do something on Edger, or is your Linux box
No, it's
problems?
I can tell you what I'm doing.
Hello, finally. I'm having microphone headphone issues. But anyway, hello.
Hello.
I can hear you.
Hi, Dawn.
I can't show anything because I can show a brick, but that's about all that it's I've got display functions and some nice graphing functions, and the ability to look at some fast moving data in the new version, but it's at the moment it's a brick.
Okay.
And I can transfer it to one of my other machines. I just wanted to get that machine running because that was my that's got the most memory. It's my development machine, and I'm pissed, but that's okay. I may have mentioned I bought an optical table to do holography, which weighed about 1,000 pounds, literally steel, gigantic, and I moved it into a storage unit, and then spent the next month trying to work out how to get it into my storage unit through a door which was smaller than the table,
Oh dear.
and went through all sorts of iterations about renting an engine lift, and it was painful. I finally there's a construction site next door. I finally went to the construction site, talked to the foreman, and said, "Here, there's $100. Have you guys move it." And half an hour later, it was all set up.
All right.
It's it's I was all sorts of clever things, tipping on its side and putting eye bolts in the thing and suspending it from I beams. No, they sent over 5 heavy guys. I helped, and they moved it, put it on the base, and they were happy. I was happy.
That's
Very
great.
low tech solution.
Yeah.
Sometimes high tech is not needed.
Yeah, no, I was literally up nights trying to work out how to manipulate this thing, and it was scaring me. And it's they had forklifts. Forklifts are good.
Oh yeah, that helps a lot.
Yes, it still took a lot of effort, but it didn't kill me.
How did you get it off the truck into the storage unit to begin with?
Pallet jack. It was filthy. I had to put it into another storage unit. They'd put ceiling tiles on the surface, so I had to clean and polish that, get the ceiling tiles off, disassemble the machine. Um, it's a beast. It's 4 by 5 feet, and honeycomb steel with quarter 20 drill holes all over the surface.
What what are you going to use this for?
Holography.
Oh,
You
okay.
mount lasers and the optical stuff on that, and it's a very stable surface,
Right. I could see why you would need stability. I mean,
and it's also for the tunneling microscope. Um, I've got a number of other little optical things that I'm going to be playing with. That that require a great deal of stability.
So 4 foot by 5 feet by how thick is the steel?
Probably 10 inches.
Wow, that's a lot of steel.
No, it's a beast. Yes,
10 inches
it's
thick steel.
yes.
Oh
Well, it's a
my
honeycomb
god!
steel. There are two. No, it. I'll send you pictures. It's a monster, and it's on a truss, so it's on a concrete floor on its own truss. Um, it doesn't vibrate,
Cool.
and somebody had one they were selling real cheap because it had been abused, and you know generally I found that the smaller ones are more expensive than the bigger ones because of the problem moving them.
Yep.
But it was pouring with rain, and they had a whole bunch of construction workers sitting around doing nothing. I went by the bank, took out $100 in cash, handed it to the foreman, and said, "You move table."
Por favor.
Yes, yes. His English was, you know, responded quite sharply to the $100.
All right. Anything else going on?